To determine the spare space in an existing 1-inch liquid-tight flexible metal conduit, or LFMC, we must calculate the total cross-sectional area of the conductors currently installed and subtract the value from the allowable fill area of the conduit. The question identifies the existing conductors as two number 10 American wire gauge, or AUG, THW wires, two number 12 AWG THW wires, and one number 12 AWG bare-stranded wire. The problem statement notes a discrepancy in a published calculation related to the cross-sectional area of the number 12 AWG THW wire. The published calculation uses a value of 0.260 square inches for the number 12 AWG THW wire, while the correct value is 0.181 square inches. We will now perform the correct calculation. Firstly, determine the cross-sectional area of the two number 10 AWG THW wires. According to the information provided, each number 10 AWG THW wire has a cross-sectional area of 0.666 square inches. Therefore, the total cross-sectional area of the two number 10 AWG THW wires is 2 multiplied by 0.666, which equals 0.1332 square inches. Secondly, determine the cross-sectional area of the two number 12 AWG THW wires. As previously stated, each number 12 AWG THW wire has a cross-sectional area of 0.181 square inches. Therefore, the total cross-sectional area of the two number 12 AWG THW wires is 2 multiplied by 0.181, which equals 0.362 square inches. Thirdly, determine the cross-sectional area of the one number 12 AWG bare-stranded wire. According to the information provided, the number 12 AWG bare-stranded wire has a cross-sectional area of 0.60 square inches. Fourthly, calculate the total cross-sectional area of all conductors. This is done by summing the cross-sectional areas calculated in the previous steps. The total cross-sectional area is 0.1332 plus 0.362 plus 0.60, which equals 0.1754 square inches. Fifthly, determine the allowable fill area of the 1-inch LFMC. According to the information provided, the allowable fill area for a 1-inch LFMC is 0.3490 square inches. Finally, calculate the spare space in the 1-inch LFMC. This is done by subtracting the total cross-sectional area of the conductors calculated in step 4 from the allowable fill area of the conduit determined in step 5. The spare space is therefore 0.3490 minus 0.1754, which equals 0.1736 square inches. Therefore, the spare space in the existing 1-inch LFMC is 0.1736 square inches. It is important to consult the National Electrical Code, or NEC, for the specific requirements related to conduit fill. The NEC provides tables that list the allowable fill area for different types of conduits and the cross-sectional area of different types and sizes of conductors. Always refer to the latest edition of the NEC for the most up-to-date information. When calculating conduit fill, it is crucial to use the correct values for the cross-sectional area of the conductors. Using incorrect values, as demonstrated in the initial calculation, can lead to errors that result in an overfilled conduit. Overfilled conduits can cause overheating of conductors, which can lead to insulation breakdown, short circuits, and fires. It is also important to consider the derating factors for conductors and conduits. When multiple current-carrying conductors are installed in a conduit, the ampacity of the conductors must be derated to account for the heat generated by the conductors. The derating factors are specified in the NEC. In addition to the NEC, local electrical codes and regulations may also apply. It is important to consult with a qualified electrician or electrical inspector to ensure that all electrical work is performed in accordance with applicable codes and regulations. The type of insulation used on the conductors also affects the allowable conduit fill. Some types of insulation, such as THHN and THWN, have a smaller cross-sectional area than other types of insulation, such as THW. Therefore, using conductors with THHN or THWN insulation can allow for more conductors to be installed in a conduit. The number of bends in a conduit run also affects the allowable conduit fill. The NEC specifies that the number of bends in a conduit run should be limited to no more than 360 degrees between pull points. Excessive bends can make it difficult to pull conductors through the conduit and can also damage the insulation on the conductors. When pulling conductors through a conduit, it is important to use a pulling lubricant to reduce friction. Pulling lubricants can make it easier to pull the conductors through the conduit and can also help to protect the insulation on the conductors. The size of the conduit should be selected based on the number and size of the conductors that will be installed in the conduit, as well as the allowable fill area specified in the NEC. It is always better to use a larger conduit than is strictly required, as this will provide more room for future expansion and will also make it easier to pull the conductors through the conduit. When installing conductors in a conduit, it is important to avoid damaging the insulation on the conductors. Damaged insulation can lead to short circuits and fires. If the insulation on a conductor is damaged, the conductor should be replaced. The use of proper tools and techniques is essential for safe and effective electrical work. Always use insulated tools when working on electrical circuits and always follow proper lockout/tagout procedures to ensure that the circuit is de-energized before working on it. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock and other hazards. If you are not qualified to perform electrical work, you should hire a qualified electrician to do the work for you. In summary, calculating the spare space in a conduit involves determining the total cross-sectional area of the existing conductors, subtracting that value from the allowable fill area of the conduit, and ensuring that the conduit fill does not exceed the limits specified in the NEC. It is important to use the correct values for the cross-sectional area of the conductors and to consider derating factors, local codes, and other relevant factors. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns. This careful approach ensures safety and compliance with electrical codes.